Dun, 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 dun. Good morning, folks. It's me again. Yes, I'm Lord Young, also known as Mr. Young. Welcome back to physics. My voice is still a bit funny today, so I want to do another little video to talk about total internal reflection. So let's see what we need for this practical. Turn this bad boy around. Now, let's see what we've got here, folks. You will need a power pack, a array box, a couple of these black cards, specifically one with a single slit, and one to put in the back so you don't blind your colleagues. You will also need a pencil, possibly an eraser, a piece of paper, possibly, preferably white paper, a glass block, rectangular, a ruler, a protractor. Okay, folks, these are the items you will need, and you're going to switch on your power pack. 12 volts. 12 plus 0 is 12. Your light is on. You put the cards in there so not to blind your colleagues, folks, and single slit at the front. There we go. Awesome. Look at that lovely ray of light there. Okay, so what we're going to do is we are going to, you guessed it, folks, we're going to draw around our glass block. Let's see if I can set this up and do this in a skillful manner. Oh, it's turning, okay. Right, so let's see, yeah, that's looking pretty good. Draw around your glass block, folks, like so. Okay, lovely. And then, don't draw any normals yet, folks. What I want you to do is, as you will see, when the light goes through the block, it refracts because it's moving from a lower density medium, the air, into the higher density medium, the glass. So it bends towards the normal, okay? And then when it comes out, it bends away from the normal because it's moving from high density material into low density, the air, all right? But watch if you do this. If I move this round, what is going on here, folks? Look, it is going in. It's going in, it's refracting. It's bouncing off this wall and coming back out here. What on earth is going on there, folks? Well, it's another phenomenon called total internal reflection. And I want you to mark on your drawing dots where the light is coming from, where it's going in. Okay, we're going to draw a line here with the ruler. Where it's coming out and where it's shooting off to, that's the emergent ray, incident ray, emergent ray, and also if we draw a little dot where the light is bouncing, where it's hitting you can see where it's hitting the other wall there, okay? And with these points, folks, you should be able to draw a lovely diagram. Let's see if I can do that now. Use your ruler, join up the lines, arrow, okay? Incident ray. And then it hits the opposite wall, like that. It bounces off. Like this, and then it comes out the emergent ray like this. Okay. Folks, this is the total internal reflection. And then, here, I want you to draw a normal. Look at that beautiful picture. And then I want you to measure this angle. And measure this angle. And this is going to be theta I for incident and theta R for reflected. Because look, this bit is acting like a mirror now. Isn't that cool? Bonus points if you draw normals here and here as well. And measure the angles with your protractor. Okay, folks, that is your mission. Should you choose to accept it, which I'm sure you will because you don't really have a choice. So, off you go and good luck. See you on the other side.